Welcome. In this video I'm going to show you how you can perform a post-hoc analysis after a goodness-of-fit test using goodness-of-fit test on residuals. So with Python, and what I mean with this is that I'm not going to compare each category with each other possible categories. That would be a pairwise comparison. I have separate videos on that, but I'm just going to look at the category and its expected count. Now, the alternative of a goodness of fit test would be a binary test, so that's also possible. So again, I have separate videos on that. I'm currently using Python version 3.12, and this video will focus on just showing you how you can obtain the output. I'll need some example data, so I'll import pandas, and then I'm going to load the general social survey data from 2012, adjusted for some example purposes. I actually don't need all of its data, I just need one nominal field, so I'm going to be using the mar1 field, which was actually the marital status, as my nominal field. To give you a quick impression, the frequencies using the value counts, and that tells me that, for example, 79 people indicated to be separated. I have actually my own library that actually has a function that could just do all of this in one go. But in this video, so here's what that would look like. But in this video, I will skip that part and I will simply show you how you could do it without that. So first of all, if I'm not allowed to use libraries, then also not Panda. So I'll convert the data to a list. So it's actually a non-Panda series, but a Python core data type. Remove the missing values, so that can be done by ignoring the not a numbers. And if I just want to see the categories, I can convert the list to a set, which actually will remove any duplicates. So these are the different categories. I wanted the different counts, so let's put those in as well as a dictionary. So I'm just going to loop over and use the count function and how often each of those occurs. So again, there's that 79 for separated. I'll do the same for my expected counts. If you have all expected counts equal, you can just take the sum of the frequencies and divide by the number of categories. We can now actually perform any of the goodness of fit tests. So for example, a Pearson chi-square goodness of fit test, but there are others. I have separate videos on each of these, so I'm not going to go into too much details for each. I will be using the SciPy stats library for that with chi-square to get the chi-square distribution. I also have separate videos on if you don't want to use that for some reason. The degrees of freedom will always be 1 because I'm just comparing divorced versus and each category on its own versus all the other categories. What I'm doing then is selecting the number of categories we have, the total sample size, and then I loop over each category. I get its observed count, its expected count, and then the other category is basically all the other categories. So that's going to be the total sample size minus the observed count, and similarly for the expected count of all the other ones. I can then calculate the chi-square statistic, which is simply the observed count minus the expected count squared divided by the expected count, and that for both of them. Then the significance, I'll use the cumulative distribution function, and then 1 minus that because I want the right tail. I adjust it with Bonferroni. There are multiple ways of adjusting for multiple testing, but the easiest one is probably this Bonferroni, which says you take the observed p-value and multiply it with the number of categories, unless that's bigger than 1, because then you should just say 1. And then print out the result. So that's what this will look like. So for example, with married, the test statistics was 34. Which has a significant of 4.54 times and then e minus 0.9, so that means this 4.54 needs to be divided by 10 to the power of 9, so that's very small, and the adjusted version is also still extremely small. We usually look at the adjusted one, and if that's below a predefined threshold, we would speak of a significant result. In this case, with widowed and separated, it seems to be not significant, and also divorced isn't, but never married seems to be significant, and married seems to be significantly different from the expected count. Alright, I hope this video was helpful. And if you want to see how you can do other tests, I have separate videos for each of these as a goodness of fit test, and then you can adjust this part in the code to get that one. Alright, thank you for watching, and hope to see you in the next video.